In previous class, we have discussed the key value data store. In earlier classes, we have discussed NoSQL database and four kinds of NoSQL databases we talked. And out of four, key value store we discussed. Next category of NoSQL database is document oriented databases or document store. Any one word we can use. As the name indicates, it is referring document. And very easy way of understanding this is when we have key value, so in place of value we have now document. So those applications where document oriented data is to be managed. So that is the objective of the development, and we see here what are the document oriented databases or document oriented data store. So document oriented databases are similar to key value databases in that there is a key and value. In key value we have key and corresponding value. Here we have key and corresponding document, but in what way they are represented, so we will see here. But analogous, you can compare these two. But in a document database, the value contains structured or semi-structured data. This structured semi-structured value is referred as a document. So here document can be semi-structured data. You know JSON and XML data. Semi-structured data we refer where partial structure is present. Okay. One definition of structure is relational database. It is one end, and unstructured means text data. And between these two ends, somewhere some partial structure can be identified. Those kind of representation of data we call semi-structure. Okay, so XML is one kind of semi-structure. JSON document, they are also semi-structured. So there are several document oriented databases depending on what kind of document structure they support. So this structured semi-structured value is referred as document. And very popular database, that is the MongoDB, all of us are aware. So there are several document oriented data stores depending on the kind of document format like JSON, XML, etc. they support. So MongoDB, CushDB, DocumentDB, okay, and there may be more. So this MongoDB is very popular, and on YouTube you may find some information, one or two video that I don't remember what are the contents of those. So you can see that, and later if I upload any video, that can be consulted later. So in document oriented database we have database, and in database we define as collection. There are several collections, and in one collection we have several documents. Okay, so we have document number 1 key and value, document number 2 key value, like that. Exact representation and how in form of this document database we store and retrieve, we will discuss later. But roughly at this stage you can assume that the document database contains collection, and each collection has several documents. So this is database, this is collection, and one collection means several documents. This is one simple example. If we take relational data, because we are taking a relational database example because we are familiar with it, we are comfortable to understand. So there are two rows, two tuples, and if they have to be represented in a document oriented database, so this is the representation you see here. This is ID, this is first student first name, and then phone number, and these two braces, curly braces. And similarly second row is represented here. Okay. So for easy understanding I am showing, but exactly in MongoDB how it is done we will discuss later. So this is student relation or schema, and this is document schema. Student relation represented in document oriented database schema. Schema means simple like this complete one unit, it is referring as one document. This is another document. So how document is represented, that structure we call schema, and contains inside document they are the values. So as a whole document is so and so like. And this is another example. So 3 records are here, and this is 1, 2nd and 3rd. Employee 100, employee 101. And when we have editor and we write, then this is the mode of writing. Okay. Now we come about some theoretical concept level issue. Document store. Characteristics of document data store are high performance and flexibility. Scalability varies depending on stored content. What contents we store, that based on that we will decide the complexity. Complexity is low compared to tabular, object and graph data store. So relatively key value you can say somewhat complex, but compared to others it is easy compared to. So following are the features of document store. Document stores unstructured data. Storage has similarity with object store. Data are stored in nested hierarchies. For example, JSON format data model, XML document object model. In XML this is one standard DOM, or machine readable data as below. Hierarchical information stores in a single unit called document tree. Logical data stores together in a unit. Querying is easy, for example using section number, subsection number and figure caption and table heading to retrieve document partitions. No object relational mapping enables easy search by following paths from the root of document tree. Transactions on document store exhibit asset properties. Typical uses of document store are office document, inventory store, forms, data, document exchange, document search, etc. Demerit of document store are incompatibility with SQL and complexity for implementation. So they are disadvantages. You know CVS, JSON and XML format. CVS, you know, comma, separated values. It is CSV, I think. CSV, right? CSV means comma separated values. Okay, so it is one representation of data. The values are separated by comma or any delimiter or symbol. JSON is another structure or representing data, and XML. So if we have three kind of files, then you will see in CSV comma separated values, we do not have any kind of hierarchical arrangement or hierarchical structure like. But at the same time, you will find in JSON and XML some kind of that structure we can identify. So CSV does not represent object-oriented databases or hierarchical data records. We are not able to identify any kind of hierarchy or hierarchical relationship among the data represented in form of CSV. JSON and XML represent semi-structured data, object-oriented records, and hierarchical data stores. JSON JavaScript object notation refers to language format for structured data. JSON represents object-oriented and hierarchical data, records, objects, and resource arrays in JavaScript. So here when we say document, that means it has some kind of identifying features in form of hierarchy or some object. Okay, so they are suitable for making or modeling in terms of document. So how do we represent data in CSV and JSON? It is wrongly I have written it is CSV. So here we will take one example and we will try to represent data in form of CSV and JSON, and later we will see one XML example. Assume Preeti gave examination in semester 1 in 1995 in 4 subjects. She gave examination in 5 subjects in semester 2, and so on in each subsequent semester. Another student, Kirti, gave examination in semester 1 in 2016 in 3 subjects, out of which 1 was theory and 2 were practical subjects. Presume the subject names and grades awarded to them. We can assume any appropriate values for subject name or grade values. Write 2 CSV files for cumulative grade sheets for both the students. Point the difficulty during processing of data in those 2 files. Write a file JSON format with each student grade sheet as object instance. How does the object-oriented and hierarchical data records in JSON make processing easier? Okay. So you see here, how do we represent data using CSV format? 2 CSV file for cumulative grade sheets are as follows. So CSV file for Preeti consists of the following 9 lines, each with 4 columns. So here you see semester, subject code, subject name, and grade. So you see first semester, this value, then subject code, then theory of computation, and this is some grade 7.8 value. So similarly second one. So in this way all can be written. So second student for Kirti consists of the following 5 lines with each 5 columns: semester, subject type, subject code, subject name, and grade. So this is 1 theory EL 101, analog electronics, and this is the value. So now you see here how many records it is written here. She gave examination in 5 subjects in 2 semesters, okay, and each subsequent semester. Another student gave 2016 in 3 subjects, out of 1 was theory and 2 practical, okay. So you see here this is one, okay, this is for second student. So a column head is a key and number of key value pairs here, how many? 4 multiplied by 9. So there are 9 courses or 9 semester. We have to go back to the previous slide. Preeti grade sheet CSP and 5 multiplied by 25 Preeti CSP, okay. So depending on the number of courses, it is written 3 theory courses and 2 practical courses. In case of it is written here 3 subjects, out of which 1 theory and 2 practical, okay, 16. So you see here when we have comma separated values, so for first student we have 4 values per subject grade, but for second student we have 5 values, okay. So 1 theory is written here or practical is written here like that. So how many courses have taken by first student and second student, based on that number of values will appear. So if we try to merge both files, then what will happen? For first student the record, 1 record has 4 values, and for another student 1 record has 5 values, okay. So if both data files are merged, then and we do some kind of processing, so the program should be able to understand 1 record is having how many number of values, only then it can do some desired processing. So either we should make program somewhat more complex, based on that this is a student, then this kind of processing will take place, and if 4 values are there and 5 values are there, then this processing will take place. But if we merge both file and we want to perform uniform processing by a single program on both kind of data of the student, then it is not possible. So how we can do, or if any other structure is there, something is written here. Therefore when processing student records, merger of both files into a single file will need a program to execute key value pairs separately and then prepare a single file. So this is one problem here. Now we have JSON representation. How JSON representation this can be solved easily or not. So JSON gives an advantage of creating single file with multiple instances and inheritances of an object. You see in object oriented programming we have inherited some, we can specialization generalization one feature. Similarly inheritance we can make more specialized class, okay, subclass, superclass, like that. So that feature makes something interesting here. So JSON gives an advantage of creating single file with multiple instances and inheritances of an object. Consider a single object JSON file, student grade sheet JSON, for cumulative grade sheet of many students. So student grade object is top in the hierarchy. Each student name object is next in the hierarchy, with object consisting of student name, each of number of instances of subject code, subject type, subject title, grade awarded. Each student name object instance extends and subject grade object instances. So here this is somewhat not readable, but in next slide you can read it. This is the contents of JSON file. Here you see this is curly brace, some definitions are written here, and ID 201, ID 202, okay, ID 200. So student name Kirti single, then a source, okay. So those students who have used this JSON file format, okay, they can understand how the data is represented here. So 203 ID, and similarly XML is a extensible, simple, scalable language. It itself describing format describes structure and contents in an easy to understand format. XML is widely used. The document model consists of root element and their sub-element. XML document model has hierarchical structure. XML document model has features of object-oriented records. XML format finds wide use of data stored and data exchanges over the network. An XML document is semi-structured. Document store appears quite similar to key value store and object store. They are complex in implementation and SQL incompatible. They have no object relational layer for mapping, and thus enables agile development of text analytics. No sharing of data takes place into tables, although the values stored as document follow structure and encoding of the managed data. The database stores and retrieves documents such as XML, JSON, BSON, binary encoded script object notation for object. So these document store, they store document in so and so format. So somebody asks question, this is my document data store or document data management system. So natural question will appear, what kind of format of document it support, whether it supports JSON or it is supporting XML like. The documents are self-describing, hierarchical, tree structured consisting of maps, collection of scalar values. The documents stored are similar to each other but do not have to be the same. Some of the popular document data stores are KutchDB, MongoDB, TerraStore, OrientDB, RavenDB. Certain NoSQL databases enables ACID rule-based transactions also. So in all document store database ACID property is not there, in some may be and some may not be. So we have to check whether it is providing or not. Certain NoSQL databases enable ACID rule-based transaction also. Example of document data store are MongoDB, Apache, Couchbase, and MarkLogic. CouchDB uses the JSON store data, HTTP API for connectivity, JavaScript for query language, and MapReduce processing. So for Kutch database, CouchDB, JSON data store is the data, HTTP API for connectivity, and JavaScript for query language, and MapReduce for processing. So CouchDB has this facility. So document JSON format, CouchDB database. It is Apache. CouchDB is an open source database. Its features are: CouchDB provides mapping functions during querying, combining, and filtering of information. CouchDB deploys JSON data store model for documents. Each document maintains separate data and metadata schema. CouchDB is a multi-master application. Write does not require field locking when controlling the concurrency during multi-master application. CouchDB querying language is JavaScript. JavaScript is a language which documents use to transform. CouchDB queries the indices or indexes using a web browser. CouchDB accesses the document using HTTP API. HTTP method are get, put, and delete. CouchDB data replication is the distribution model that results in fault tolerance and reliability. So document JSON format. In MongoDB, the JSON format, MongoDB document database provides a rich query language and construct such as database indexes, allowing easier handling of big data. Example of document in data store. This is way of writing JSON format. The document store allows querying of the data based on the contents as well. For example, it is possible to search the documents where student is the first name. Student's first name is Ashish. Document store can also provide the search values, exact location. The search is by using the document path. A type of key accesses the leaf values in tree structure. Since the document stores the schema less, adding fields to documents XML or JSON becomes a simple task. Document architecture patterns and discovering hierarchical structures. You can apply your common sense. If I say identify the structure in document, so the possible answers will be: document may have some like heading, topic name, document title or not. Second, paragraphs in document, okay, section or subsection are present or not. So basically all these are some structure that one can identify, okay. And if I say there is a text, I do not have any such definition document format, then it is difficult to say whether it will have paragraph or not. Like, so somebody can argue that inside paragraph we have text, okay, that can be. So that's why semi-structure refers partial structure is being identified here, okay. So we were here. Document architecture patterns and discovering hierarchical structure. Following is the example of XML document in which hierarchical structure discovers later. Structure is discovered later, like what should be. Figure 3.5 shows XML document architecture pattern in a document fragment and document tree structure. This is the root, branch, value, tree representation. So this is XML representation and this is corresponding tree, okay. You see here D4, here D4 and F6 header. This is called tag. So F is corresponding to 6 and D4. These two are then C. So C tag includes D and F. Similarly, B tag will include D and E, B tag, and A tag will include B and C. So this is outer. The document store follows a tree-like structure similar to directory structure in file system. Okay, we also have the file system. Beneath the root element, there are multiple branches. Each branch has a related path expression that provides a way to navigate from the root to any given branch, sub-branch, or value. XQuery, XPath, or query languages, they are the name of the query languages, for finding, extracting element and attributes from XML document. The query commands use subtrees and attribute of documents. The querying is similar as in SQL for database. XPath treats XML document as tree of node. XPath queries are expressed in the form of XPath expression. Following is an example. XPath is name of language, okay. It is a query language for XML data. So given example, XPath expression let outermost element of XML document is A. So an XPath expression, you see here A, then this oblique, opposite oblique, slash, reverse slash, okay. So select C element that are children of B, elements that are children of A. C are the element of B, and C are children of B, and B are children of A, that form the outermost element of the XML document. And XPath expression A slash A, B and C equal to 5, select element B and C that are children of A, and value of C element is 5. Okay. And XPath expression, this A, B, C, select element C and D, where C is a child of B and C is a child of B, and B and D are children of A. Okay. B and D are children. You will find this kind of syntax in writing query when we have of this document data store. XML and JSON path. JSON both are designed to form a simple and standard way of describing different kinds of hierarchical data structure. Okay, data we want to describe using some hierarchy or hierarchical arrangement. They are popularly used for storing and exchanging data. The following example explains the concept of document stored in JSON and XML hierarchical records. You see here in this example, XML and JSON data fragment, some part of record. So this is student. You see here this one square brace. Okay, left square brace, and this is the right square brace, and between these two we have name, roll number, and then names Sandeep and roll number, this one. And now same thing is represented here in XML. Okay, so students, okay, and this is student. So this tag outer, and then we have student tag, one student description, second student tag, second student description, name Sandeep Joshi, and here Ashish Jain, and roll number. Okay, so same data is represented here. So JSON and XML equivalent. When compared with XML, JSON has the following advantages. XML is easier to understand, but XML is more verbose than JSON. Okay, we can see here more text is appearing in XML compared to this JSON. XML is used to describe structured data and does not include array, whereas JSON includes array. JSON has basically key value pairs and is easier to parse from JavaScript. To concise syntax of JSON for defining lists of elements makes it preferable for serialization of text format objects. Document collection, it is a collection. A collection can be used in many ways for managing large document stores. Three uses of document collections are: group the document together similar to a directory structure in file system. Okay, in the beginning we discussed document. In this document oriented database we have collections, and each collection has several documents. So that the description we are dealing right now. So a collection can be used in many ways for managing large document stores. Three uses of document collection are: group the documents together similar to a directory structure in file system. A directory consists of grouping of file folder. Enables navigating through document hierarchies, logically grouping similar document and storing Bayes rules such as permissions, indexes, and triggers. Special procedures are on some actions in a database. A collection can contain other collections as well. Okay, collection can also have other collections. Now, if we try to compare this document, this is object store. Okay, this is not, but object store is also similarity with key value. So we will discuss in later class. So two document data stores you should be familiar how to use. What are those? So KurukshetraDB and MongoDB. Okay, so in next class we will discuss another kind of this NoSQL database, and then we will later classes we have MongoDB, etc. Okay, thank you.